Cool. All right, back half. Go through it as fast as we can, so got a little bit of time at the end. If you got any questions, anything like that, but ding, round 2, pick up where we left off. Reading the problem explains the problem. What can you cross out right away? Okay. And D is exactly correct in degrees. Just making sure that you understand what radians actually are. That was new to us this year. Actually, B is. There we go. Words. If I have a negative angle, means I start on my positive x-axis and I go around that way. I'll go around 240 degrees, which leaves a reference angle of 60 degrees. But I don't want 60 degrees. I want radians. What? 240. Oh. I'm thinking, yeah. There we go. There we go, 240. Oh, options. You can say negative 240 plus 360 to find a coterminal angle. You could do negative 240 and then times pi over 180, or find its reference angle and then turn it into radians. I could turn that into radians to begin with. Okay, you got a bunch of different options, right? Work entirely in degrees, turn your answer into radians at the end, or anywhere along the process, turn it into radians. But maybe a note to yourself, a reference angle is always positive, and it's always formed with the x-axis, never the y-axis. Yeah?
So to find the, convert it to radians, you
pi over 180. Because 180 degrees is pi radians. You could use anything else. You could use 2 pi is to 360. You could use anything on there as a conversion factor. But since 1 pi is to thing, it's called a unit words. The unit rate of a thing is when you compare it to 1. Like miles per gallon. This is how many miles I can get for 1 gallon. Dollars per hour is how many dollars I earn per 1 hour of work, is a unit rate. Since it equals 1 pi radians, it's just the one we go with. Okay. If they tell me that sine is a negative 5/13, but cosine is greater than 0, they're saying sine is negative, cosine is positive. And I got to remember in which quadrant that happens. And we'll see how true this is after this year, but all students take calculus. If you remember that. Everything is going to be positive. Only sine is positive, tangent is positive, cosine is positive. So if I want the quadrant in which cosine is positive but sine is negative, we're talking down in quadrant 4. So theta is going to have a sine value of negative 5/13. Use Pythagorean to finish off the triangle, or recognize your ratio. Remember, 3, 4, 5, 5, 12, 13, 8, 15, 17 are the 3 most common Pythagorean triples. But once I've got that, now it does say cosine is positive, cotangent is negative, wasn't actually necessary to have that second part on there, right? In fact, you could have had either one of those to figure out it's going to be in quadrant 4. No, because I'd say they're both negative. Yeah, well, you could use either one. Okay, anyway, you do the thing, go find secant. Secant of theta is the reciprocal of who? Cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So hypotenuse over adjacent, 13/12. You notice the negative 13/12 is on there too. Looking for, do you know which quadrant? Are you putting it in the right quadrant? Do you have the right signs on things? All that kind of business. Which of these is a relative maximum of the trig function? Try to think of how do we get you to graph a thing without having the graph of the thing be the actual answer? Well, go find a very specific feature of that graph. All right, let's see what we can figure out. First, y is a sine of bx plus c plus d is our standard form for it, where a is my amplitude, d is my midline, or vertical shift. The period, distance until it starts repeating itself, is 2 pi over b. Technically, it's absolute value of b, but that never really came up for us. And the phase shift is going to be a negative c over b. Again, I'm pretty sure it's absolute value. I know it is on period. I don't know if it is on phase shift, honestly, because it never came up in our book.
What's the phase shift?
I don't think it is.
I don't think it could be.
All right, well, we have never had a b value that was negative in our class. But anyway, we got all this stuff about it. If I know that my midline is at -1, I'm just going to label the midline -1. If my amplitude is still 1, then I'm going to go above that 1 and below that 1. My phase shift, negative c over b, is a negative pi over 3. So I'll start my graph at negative pi over 3, period. 2 pi over b, b in this case is 2, so just pi. That means from here to the end of one cycle of it will be pi. So negative pi over 3 plus pi is at 2 pi over 3. Negative pi over 3 minus pi, 1, 2, 3, 4, is going to be at negative 4 pi over 3. How do I fill in the intervening space? How did I know to put it there? Quarters, right? The relevant features of any sinusoidal graph are going to occur at 1/4 of its period. So if the period is pi, that means these quarter marks are going to be at pi over 4 increments. Which means you got to do a lot of common denominator junk. Turn this into a negative 4 pi over 12, that into a 3 pi over 12. And let's see how much mental math we can screw up before lunch. And 4 pi over 12, 3 pi over 12 is negative pi over 12. Plus another 3 pi over 12 is 2 pi over 12 is pi over 6. Plus another 3 pi over 12 is 5 pi over 12. Right? And 5 pi over 12 is 8 pi over 12, 8 pi over 12. Hey, cool, I'm doing it right. And then 11 pi over 12. And then 14 pi over 12. And then 17 pi over 12. And on and on and on and on and on. You know what? I'm actually not going to do the back half of this because I notice every single one of my x values in my options there, they're all on this side. So I'm not going to bother with the back half of the graph. Where does sine start? We always start on our midline, okay, at 0, as it were, but that 0 changes based on the phase shift. And from there, our dance is up, middle, down, middle, up, middle, down, middle. So which of these is a relative maximum of the function? Well, here, this coordinate is negative pi over 2, 0. This coordinate is 11 pi over 12, 0. Those are maximums. Are none of them it? Oh, that's a 12. Okay. Whew. There you go. So, relative maximum, there it is. Yeah. Yeah. So, that's it. Like, that's the best way I can figure out for, all right, how do we have a multiple choice problem where I have you just graph the whole thing, and if you don't graph part of it right, you end up with the wrong answer, was, let's go find a very specific feature of it. Also, you notice the feature we were looking at, you had to find those quarter marks. And I know some of us were kind of skipping that when we were in that chapter. We would just do the phase shift, add and subtract the period, and not fill in the blanks in the middle. I saw a couple of us doing that. We want to find all the relevant features. Okay, asymptote. So same thing. Going to get ready to sketch a graph. 1, 2, 3, 4. 1, 2, 3, 4. The phase shift is still negative c over b, which is going to be a positive pi. The period is still 2 pi over b, which means my quarter marks are at pi over 2 increments. So from there, I'm over pi over 2, pi over 2, positive pi over 2, 0, negative pi over 2, negative pi. So if you wanted, you could start back at 0, but you just got to remember where your phase shift starts you at. We got an amplitude of 2, so 2, no vertical shift, so midline is 0. And secant is the reciprocal of what? Yes, reciprocal of cosine. And cosine normally starts where? Okay, at your maximum. So, up, middle, down, middle. Up, middle, down, middle, up. But what is different with a reciprocal function as opposed to the regular cosine? all explodes outwards. Everything that was an x-intercept is now an asymptote. Everything that was a maximum becomes a minimum, minimums becomes maximums. And I got a bunch of different forms of this, so on these two problems, I can't guarantee what I'm asking. I'm betting one of them is going to be sine or cosine stuff. The other is going to be cosecant or secant stuff. One of them might ask for a maximum, one of them might ask for an asymptote, one of them might ask for a x-intercept, another might ask for a minimum. It's going to say graph thing, find thing on graph. Okay? I'd say these are probably the most wiggle room off of the review that you can see. Most of them are literally, it's the same problem, different numbers. But in these ones, you are looking at, look, do you know how to graph sine or sinusoidal functions? If you can graph a periodic function and you know where all the features of it, you can do these two problems. Okay? In this case, it's asking where an asymptote is. They're all y equals thing. Why are they all y equals thing? Yeah, they should. Yeah, I might need to actually go back and, like, edit my review. Oh, some of them say x equals? So I went back and edited, but I have a couple of old copies laying around that y'all just got. Okay. I bet the Word document, I changed it, but I never saved and overwrote the PDF. That's why. Whatever. In any one of these cases, I'm looking for negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. Not you, not you. Hey, you. Someone's going to ask the question, what if there's two of them that are both the answers? Because, asymptotes repeat. What if it's the maximums and two of them are the answers? I spent a lot of time making sure the finals are perfect. If you see two answers that are both correct on something, you done screwed up. Okay? Spent a lot of time on those. It's kind of a do more work now, less work later business. You probably had your parents chew you out for something, or maybe a boss at work say if you do it right the first time, you won't have to do it again. It'll save you time if you take more time now, kind of thing. Well, if you're willing to spend 3 weeks and every spare minute you have to make the best final, then grading finals only takes like an hour. It's great. Good stuff. What's the distance between vertical asymptotes? Do you know what feature I'm asking for? If you know that in a tangent and a cotangent function, the distance between asymptotes is a period, unlike half of the period for secant and cosecant, then yay. Or did you just know that because it was on the review key? Right? So if you don't know stuff like that off the top of your head, you might have to just graph the whole thing. How do I know it's going to be distance between vertical asymptotes on the final? What if it's going to be, what is the distance between any two x-intercepts? What if it's going to be, it'd be the period again. I don't know. I can't think right now. I'm tired. I have a shrieking toddler at home. But we should probably review how to just graph the things anyway. Period on these. Remember, tangent and cotangent, those are the redheaded stepchild of the family. Those are pi over b instead, not 2 pi over b. The phase shift. Take a wild guess what one of the answers is going to have then. Phase shift is going to be negative c over b, which is pi over 8. So I start at pi over 8. And from there, the period is pi over 4. So a cotangent starts at an asymptote, x-intercept asymptote. So I'll go pi over 4 this way. So 2 pi over 4 plus pi over 4 is 3 pi over 4. Plus another 2 pi over 4 is 5 pi over 4. 2 pi over 4 minus a pi over 4. Right? 1, 2, 3, 4, 5, 1, 0. What? Okay. So you do the thing. If you need to graph it to figure out the distance between those. Not there, 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 there. Remember that cotangent graphs are a reflection of tangent. But if you recognize, if you know that the distance from asymptote to asymptote is just the period, then you can just say the period. Great. Now, if you're not going to sketch out the graph, because again, I don't know which feature I'm asking for on the final, or which version of the final. Like yours might say, what's the distance between asymptotes? Yours might say, what coordinate is midway between the x-intercept and the asymptote? Well, what coordinate is midway between these two? Amplitude is still 1. If from here to here is pi over 4, then here to here is pi over 8. This is 2 pi over 8. What's halfway between 2 pi over 8 and 3 pi over 4? Because that's where it always occurs. So remember, midpoint formula, 2 pi over 8 plus 3 pi over 8. 6 pi over 8 is 8 pi over 8. Halfway between 8 pi over 8 and divide by 2 is... Wait, is that just pi over 2? Cool. It might ask for what is the... It might just have a graph on there too. I think I had that on a couple of them. Here's a graph, and I would just say, what is this coordinate? But you have to be able to label the graph to do that. Okay? The idea is, look, we spent like 5 days on sine and cosine and secant and cosecant and tangent and cotangent graphs and how to find all the different stuff on them. Well, you're going to have to find something on a graph. Okay? Yes. That's the point. All right. So we spent like a week on that stuff, those three. Exact value of the expression if it exists. Man, this would be really easy if we knew that table for all of our trig functions. Arcsine of negative 1/2, what is it? What angle has a sine value of negative 1/2? First of all, is that even legal? What do all arcsine value, or the domain of all arcsine values has to be what? Negative 1 to 1, okay, has to be legal because there's no solution. Not bad. Between negative 1 and 1, right? So yes, legal target. What angle has a sine value of negative 1/2? Negative pi over 6, yes. Or a negative 30 degrees. Honestly, and if I'm being perfectly honest in my head, I think 30 and then convert it to negative pi over 6. And then go find the secant of that angle. Well, do we know what secant is the reciprocal of cosine. Do you know what the cosine of pi over 6 is off the top of your head? Square root of 3 over 2. Wait. This is a negative pi over 6. What does that do to my cosine values? Our cosine value is going to be positive or negative down in the fourth quadrant. Going to be positive. Okay, so if the cosine is square root of 3 over 2, then the secant is 2 root of 3 over 3. Now, if you remember all that stuff, you can just mental math your way through it. You could have this straight to answer. Or you can always reinvent the wheel. Sine is negative 1/2. Okay, negative 1 over 2. Do Pythagorean. Find the missing side. If I do the arcsine of this, I will get theta, whatever mystery theta is. Now go find the secant of theta. Secant is adjacent, is hypotenuse over adjacent, words. And then rationalize it. I actually screw up more doing it the long way. You can just reinvent the wheel by making the reference triangle. But to do the reference triangle, you need to know at the bare minimum, which is why I said all the way back at the beginning of chapter 4, you got to know your 30, 60, 90, and 45, 45, 90 side lengths. If you know those 4 numbers, you can recreate pretty much half of chapter 4. Those are the ones you got to know. So, one more time for the forgetful folk. The legs of 45, 45, 90, what's the ratios on them? Hypotenuse. Short leg. Okay, I heard all 3 of the numbers. The short leg is 1 because it's the smallest value. Smallest angle, smallest side length. 2 is larger than square root of 3, so it has to be the hypotenuse. Square root of 3 is the long leg. If you know those, you can pretty much recreate half of chapter 4. In fact, that's what chapter 4 was. It was take these things and poof, make trig. Yeah? Which is why I got all excited and happy flapped because we made the unit circle. Because it's the same thing over and over and over. So, find the measure of angle A. You see that angle that says 100? What is this triangle not? It is not a right triangle. It is not a right triangle. Boy, I tell you, the number of kids that are going to try to do the arctangent of 10 over 8. Because they'll think opposite and adjacent from angle A. Don't do that. I would bet that's one of those answers. Don't do that. It is not a right triangle. You are not allowed to do right triangle trig on it. But we did learn. I see side angle side. Side angle side tells me I can do law of cosines to start finding things. I'm going to go find little b first. Yes, this is 2 steps. You do have to do the 2 steps. It's going to be side length squared plus side length squared minus 2 side length cosine of angle sandwiched in between them. Start typing. Yeah? What?
Did we get that formula?
I will put law of cosines up.
And don't forget that.
Oh, there's 2 formulas. What about law of sine?
Law of sines and law of cosines. I will put those up. In fact, we'll make sure our guy doesn't erase them here.
There's also that E1.
Kyle. His name's Kyle. Kyle's our new custodian.
Oh, I thought you said about Dante. Jake Dante. I think his name's Jake.
Like that.
His name's no, obviously. I actually think his name's like Jake. I haven't put it in the calculator.
Okay, so we had what? A of t is pert. Then we had our amount in terms of time could also be our principal times 1 plus rate over n. T. Oh, yeah. And then we got a squared is b squared plus c squared minus t. There. Good call. Okay, for anyone who just typed this, look at the top line of your calculator. Are you in radians or degrees? Be oh so careful about that. That says 100 degrees, not radians. Remember, every time you reset your calculator, it defaults back to radians. Might not be a bad idea. But before I come around and hand out finals, I also have everyone clear out their calculator.
You can write notes in the program.
Wait, what? That still wouldn't work.
Yeah, if you want to rewind about 18 years, I programmed Monopoly, Wheel of Fortune, and Link's Awakening into my TI-83 in high school. I wasn't either. I just had a lot of time and I was bored. So I looked it up online and started pressing buttons. Yes, it resets everything. Bummer. I think you can, I think there's a way to hard press in there the apps. So if you code an app in there, it'll stay. But you got to be pretty determined for that. Anyway, you do the thing. About how much? 849. Okay. Now you notice 13A5 is one of the answers up there. That is not angle A. That's side length B. Got to keep going. Now that you have your new side length, you have the option of either law of cosines. So I can now do the arc cosine of 10 squared minus 8 squared minus that answer squared all over negative 2, 8, that answer. I could do that to find my angle. I could do the law of sines. You don't need that. That is that rearranged. I ain't giving you the calculator shortcuts. I'm giving you the formula itself. If you plug those numbers into that formula and solve for angle A, this is what it comes out as. Or I can use the law of sines because now I have a control pair. If that's my control pair, I now know the sine of 100 over this is the sine of 10 over that. So I will shoop-a-shoop. Arc sine of that 10 sine of whatever that answer was over 8. Either one of those. Okay? Either one will work. Don't have to what? Is there? If it's a cute ass, you got to be careful. That's a big ass. It's got an obtuse angle. Because we started with an obtuse angle, you can't have a second triangle. If triangle ABC's got a big booty, you know what you're getting into. Don't worry about it. Okay? So, either one of those, I'm guessing you know how to press buttons. Make sure you're in degrees. I'm betting some of those answers up there are also if you were accidentally in radians. Couldn't I just? I would bet the 1.45 was probably one of the radian answers, though. This is how the ACT is done, too. If you rely on the calculator and you just don't think, you might get bad answer. Now, if you know logically, well, there's no way that can be 1.45 degrees. Like, it's just not proportional, even if it's not drawn to scale. Then okay, go ahead and get rid of it. Solve the system work must be shown to receive credit. Why is that line on there? You can ref and know exactly what the answer is. Guess what? If your work does not match your answer, I'm tossing out the whole thing. Do it for real. Okay? Now, it does just say solve the system. It doesn't say you have to do it by matrices. So if you want to go old school like you're back in Algebra 2, you can. I personally would prefer to do maybe a row 3 and row 1 swap. 5, 1, negative 3, negative 13. Why did I do it that way? If I can start with the 1 in the top left or bottom right, then I can work my way around that circle. So from there, I choose to say row 2 minus 4 row 3s. Row 1 plus 3 row 3s. Okay, take that by 3 is 6 and add it. That by 3 is negative 12 and add it. Take that by 3 and add it. Gone. Take that by 3, 24. Huh. Take that by -4 and add it. Take that by -4 and add it. That by -4 and add it. That by -4 and add it. And nothing down here yet. I heard someone say something 11. And take this guy over 11. So I can turn this into a 1, this into a -1, that into a 1. Here. Let's get some space to write here. So now I can say row 2 plus 19 row 1s, row 3 plus 4 row 1s, oh wait, minus 4 row 1s. Oh, yes. Sorry, they're blathering and I can't tune it out for auditory processing. It's also why, well, okay, choice time. You're right, choice time. I could use that -1 to knock out both the 19 and the -4, but then I would have to move that -1 into the second row, wouldn't I? If I knock both of these out, I would need him to come into this row so I got 1s on my diagonals. So that's an option. Or, because there's a 1 up here, I could knock out the 5 and the 2 right now. Yeah, remember? Choices. Okay, so let's do that. I like that better. Row 2 plus 5 row 1s. Row 3 minus 2 row 1s. Times 5 and add it, gone. Times 5 and add it. Times 5 and add it, still 0. Times 5 and add it is a -7. Interesting. Times, what was it? -2 and add it, gone. -2 and add it. Right? Yeah, -2 and add it. And then while we're here, divide by -2. That's a 1. See, now I'm all discombobulating. Untake that middle row. I'm betting at least one of my answers starts with that, right? Has a -1/2 as a y value. Yeah, B. I could stop there. I could keep going. Well, if I got a -1/2 there, assuming I did my work correctly, that's only one option out of the 5. You got a choice. Honestly, if you went to that point and you had magically checked that you knew that was going to happen, I would, by process of elimination, say, woohoo, and move on. If it's like that, Since this is missing the rest of the decimal train, that would be an incorrect answer versus a correct answer. That's the only place where you'd have a choice between decimal or fraction, where basically I've been hammering all semester that decimal's bad. If you get decimal answer, you better be very sure of yourself. Yeah, I kind of hammer on that throughout all of the incorrect answers is if you got thing as a decimal and you had to round it in any way, shape, or form, you're probably wrong. Probably. Solve the system. You notice there's no just plain number over there. Here we go. Correct. There is one that we're going to get rid of. Come on, you. There you go. All right. If you want, you could maybe take 2 of the rows times 2, or take this row times 2. Now you can use this 2 to knock out both. Like, if you are adamant about needing to start from the top left or bottom right corner with a 1, you could multiply to have the effect of a 1. Personally, I'm going to see if I can take row 3 minus 3 row 2s. I'm going to see if I can keep this here. I might be able to, I might not. I don't know. I'm just going to try. So, times the negative 3 is negative 6, add it. Times the negative 3 is negative 3, add it. Times the negative 3 is 24, add it. Times the negative 3 is negative 33, add it. While I'm here, divide by a 10. I'm also going to say row 1 plus 4 row 2s. Times 4 is 8 and add it. Times 4 is 4 and add it. Times 4 is negative 32 and add it. Times 4 is 44 and add it. Right? Yeah, 13. And I see I can divide by 13. I'm also not going to touch this row. Getting a 1, negative 1, 1. What's going to happen right now if I smash together rows 1 and 2? From here, if I now say, oh, negative 3. I want you all to come back to me in about another 10, 15 years when you have children who screech like pterodactyls in the middle of the night. Then we'll talk. If I say row 1 plus row 3, the catch is I get all zeros. And if I get all zeros, what does that mean? There is an infinite number of solutions because 0 does equal 0. That's an identity. I'll also, while I'm here, say row 2 minus 2 row 1s just for grins to get rid of him. So times a negative 2 and add it, times a negative 2 and add it, times a negative 2 is 6 and add it, negative 2, there we go, times a negative 2 and add it, 9, 1, 0, negative 3, 1. Okay, right now what's going to happen if I try to eliminate either the negative 3 or the negative 2? Put X in a 0 spot or a Y in a 0 spot. You're going to be a Yorkie chasing your tail going round and round and round and round. So now I'll come out of the matrix and say what these actually stand for. That's X minus 3Z is 1. That's Y minus 2Z is 9. So if I were to rearrange those and call X 3Z plus 1 and Y 2Z plus 9, what would Z be in terms of Z? Z. That's it. That's your system. 3Z plus 1, 2Z plus 9, Z. It's not enough to just say infinite system and move on. You got to keep going and find the answer. 30 is the only one that we did not cover. I'm going to still say it because maybe this review video will get used next year. It'll be the only one that I don't delete. Pretty simple. To get an inverse, you swap your means, negate your extremes, and you take it times 1 over the determinant. Determinant is AD minus BC, where A, B, C, B. Correct. You'll cross this one out. I'm still saying it in case I get to use this next year. Here I get a negative 24. Here I get 30, getting a negative 54. That's it. It was formula stuff with systems. It only works with square matrices is the only way you can get inverses. There's a bunch of other stuff that goes along with it. You can play with it when you get up to calc. It's not going to affect you too much. But for our purposes, we will be crossing out 30 this year. Partial fractions. Well, I know I got to factor this into x and x minus 2. But what do I got to do before I start splitting things up? I heard one person say divide. Why do I have to divide? If the degree of the numerator is greater than or equal to the denominator, you have to divide. So we'll take a 2x squared plus 0x, placeholders are important, plus 4, divided by x squared minus 2x. 2x squared divided by x squared is 2. 2 times the stuff is 2x squared minus 4x. Change the signs, getting 4x plus 4. So that's what I'm really breaking up. It's 2 plus 4x plus 4 over x squared minus 2x. The 2 is the whole portion of this. I need to break up the fraction. The rational part is what gets exploded. So I will take only that rational part, and because there are no repeated, there's no repeated factors, There's no, oh, we didn't do example 4. I got to make sure that example 4 isn't one of your forms of the final, where you have a irreducible quadratic, because then you need an ax plus b on the numerator instead of a. Ah, crud! I gotta look through a lot of stuff. This one isn't. This one isn't, and I will make sure that we only have forms of the final that don't have that example. So x and x minus 2. Nah, you're still going to do it. I know that there was some denominator up here, a and b. I know I need common denominators. I know if I now multiply by that denominator, all this goes away, which results in 4x plus 4 equal to ax minus 2a plus bx. How does that get me my partial fraction? How does that get me a and b? There's too many variables up here. You make a system. You match them. Do I have enough things here? Here, let's go away. I know that this many x's has to equal this many x's. I know this many constant equals this many constant. So a is negative 2, b is 6. So if I replace a and b, we got negative 2 over x plus 6 over x minus 2. Well, that's close enough, right? I mean, that's pretty close, right? Don't forget your kid brother at Burger King. How many kids are going to get all the way there and be like, you know, I'm pretty freaking close. I'm just going to go for it. That's how multiple choice tests work, right? I'm pretty close. I'm just going to say this one. In fact, that is what you're supposed to do when it comes to ACT, to save yourself time. You don't second guess yourself. You just trust your instincts, young Jedi. Write it, go. All right, Directrix. Before I can find the Directrix, I need to put it into standard form. To put it in standard form, I need to know which one is squared and get all that stuff on one side. So y squared plus 6y is negative 20x minus, ew, 87. Ew. Get your y stuff on one side because that's the squared stuff. Then complete the square. Half of 6 is 3. 3 squared is 9. Did I really add 9?
No. Yes.
Just checking. So we'll have y plus 3. The quantity squared is, yes, this is a negative 80, but make sure that you separate that 4p value. To find the Directrix, you need to first know where the vertex is. Does this thing open up, down, right, or left? How do I know? That tells me that it's going to open horizontally. The negative tells me it will open to the left. So I'll have a vertex here at HK, always bass-backwards land, negative 4, negative 3. This is my 4p value. So p is negative 5, so we'll p in this direction for a focus. at -9, -3, and we'll p in that direction at x equals 1 for a directrix. Well, I would bet that number 32 on your final is also a parabola, but who says it's going to be find the directrix? What if it's find the focus? What if it's here's a point the parabola contains, what is a line tangent to it? All I'm saying is number 32 is going to be something, something, figure out crap with parabola. Blame the class of 2019. They made me this way. The class of 2019, the ones that graduated 2 years ago. I used to just have a free response final. And only one form of the final. Like our normal quizzes. Here's a question, write your answer. Where everyone did the same thing. Now I have an entire, 100 permutations of the final because they were a horrible pack of cheaters. I mean, I know that you guys are too, but I caught them red-handed in class. So, 33, determine the equation for an ellipse. You notice that it was something parabola, now it's something ellipse. I'm guessing 34 is something hyperbola. We covered a lot of stuff with each of those types of conics. This one might be, here's information, write the stuff for an ellipse. Maybe they get swapped. Maybe 32 is, here's information, write the parabola. And this one is, where are the foci of this ellipse? It's going to be something, something, that type of conic, and a feature of it. Well, ellipses always start as this. Okay, they always start that way at least. If the co-vertices are -13,7 and -3,7, remember the co-vertices are always on the short end of the potato. So that means this thing is stretched vertically. If it's stretched vertically, that means that my a squared value is going to go with x. B squared will go with y. So I know that much. Also, what's always halfway in between those co-vertices? Center. So, jam a midpoint formula on that. What's halfway between -13 and -3? -8. So I know that this center is at -8, 7, which allows me to put -8, 7 in as my HK. Also, from here to here, that was 10 units. Co-vertices, the length of the minor axis gets me what? B's. Because we A to get the vertices and we B to get the co-vertices. So if this is 10 units, that means from here to here is 10 units. That means B is 5. So B squared is 25. If the major axis is 16, then I know A. And if I know A, I know A squared. What if that said, here's the length of the minor axis and here's the foci? What do foci get me? C. Remember that in an ellipse, C is the square root of A squared minus B squared. I'm debating whether I'm going to write that one. Is it up there? Yeah, it's up there. Option B. 34, find the foci of. Now it's a hyperbola. How do I know it's a hyperbola right from the get-go? Two things are squared, and the coefficient of 1 is negative. If they're different, that means it's not a circle. If they're the same, it's a circle. If they're positive and different, it's an ellipse. If they're negative and one is negative and they're different, then you got a hyperbola. So I'm going to put all of my x stuff here. I'm going to put my y stuff over here. And my constant over here. I'm going to factor that 13 out, leaving x squared plus, what's that, 30, 130, 78, two of those, 3, 6, 16, right? Question mark? Okay. Take out -2. Be very careful with your signs there. Very careful with your signs there. Complete the square. Half of 16 is 8. 8 squared is 64. Did I really add 64? No. I added 13 times 64, which is 640, 180, 720, 820, 844, question mark? 832. What?
You said 13 times 64?
Yeah.
832.
Huh. Okay. Oops. Half of -8 is -4. -4 squared is 16. Did I really add 16? I subtracted 32. So I need to subtract 2 again. So we've got a x plus 8, always half of b, squared. We have a y minus 4 squared. When I add all that up, what's that, 800 times 52? If I divide by that 52, because I do want it to equal 1, 2 over 52 reduces to over 26. 13 over 52 reduces to 1/4. Cool, I got an equation. What do I do with it? Go find your foci. Your center is still at HK, -8, 4. Does this thing open vertically or horizontally? How do I know? Oh, the A and B is determined. The A and B value determines stretch on an ellipse. Positive, negative determines on a hyperbola. Because my x unit is squared and positive, it's going to open horizontally out along the x-axis. So that means it's going to look like this. Okay. And we are going to go 4 in this direction for a vertex, and 2 in that direction, and 2 in that direction for a vertex. That still doesn't get me foci. Foci are used with c. C in a hyperbola is a squared plus b squared. 26 plus 4 is 30, square root of 30. If I'm going left and right of it, it's going to be -8 plus or minus that square root of 34. Option E. You notice if you forget a squared plus b squared versus a squared minus b squared on ellipses and hyperbolas, that 26 minus 4. Okay, so just something as simple as missing that negative can goof us up here. Asymptotes of. Well, I know I'm going through the center. Asymptotes always go through the center. But is it A over B or B over A?
E over A.
It's always, A and B is almost arbitrary. Slope is always y's over x's, rise over run. So, in this case, b squared is 36, b is 6. A squared is 25, a is 5. Because this is a horizontally opening hyperbola, I'm going to have plus or minus b over a. Wait a second. None of those look like that. It looks like we need to distribute and find them separately. Y minus 1. If I do a plus or a minus times a thing and then start adding with it? Does anyone remember from the actual lesson? You got to make two separate ones. I have to say y minus 1 is 6/5 by x plus 4, and y minus 1 is negative 6/5 x plus 4. Getting y minus 1 is 6/5 plus 24/5. Y minus 1 is negative 6/5 minus 24/5. Adding 1, which is 5/5. Adding 1, which is 5/5. Oh, minus. Where is that? Plus 29/5. B? I don't see the rest of it, but I'm assuming it's B. Okay. Write the function in standard form. What type of function is it, and how do I know? Well, it doesn't start with all my squared stuff on the right side, or left side. So we'll do that first. X squared minus 4x plus y squared minus 12y is negative 31. Now do we know what type of conic it's going to be? Circle, because I have x and y are both squared and their coefficients are the same. I still need to complete the square on it though. X squared minus 4x blank plus y squared minus 12y blank is negative 31. Half of negative 4 is negative 2, squared is 4. Yes, I really added a 4. Half of negative 12 is negative 6. Negative 6 squared is 36. Yes, I added a 36. Always x plus b over 2. Always y plus b over 2. And wait a second. Wait a second. It's right there, but then I always had to divide and get 1 on my ellipses. Which one is it? One where I don't divide. Because if they both have the same coefficients and it's a circle, we leave that denominator, since it's the same, on the other side, because that's my radius squared. So that's it. Right? Whew! We're getting there. Write the explicit formula for the sequence, and it doesn't say what kind it is. So you got to determine what are they doing with every successive term. Remember, we don't divide in this house. We multiply by things. Okay, you said they multiplied by 3 and they divided by 2. Well, we don't divide in this house. But wait. They were dividing the denominator by 2. Isn't dividing the denominator by 2 the same as multiplying by 2? So what are they doing every time? By 6. Which means I have a common ratio of 6. This is a geometric sequence. So an explicit formula, a sub n, is a sub 1 times r to the n minus 1. So 1/32 times 6 to the n minus 1. I think we need to write some geometric formulas up here. Where did purple go? There's purple. Yep, we'll throw them all up here. See if I can actually remember them. A sub 1 is number, a sub n is a sub n minus 1 plus d. N is a sub 1 plus a sub 1 is number, a sub n is a sub 1 times r, no, a sub n is a sub 1 by r to the n minus 1. Okay, those are the forms of the arithmetic and geometric. We'll probably also need our sums. S sub n is, there was 2 of them. Actually, there was 3 because this one had infinite. So I'll have to go back and clean all this up.
Wait, hold on. So your 29 class, notes on it. Did they all have like the same
I have always done, the day before the test, we do a review. The review looks just like the test. They were allowed whatever they wanted on one sheet of paper, front and back. They could write whatever the crap they wanted for the test. And they still made a point to cheat together as a group, because I used to offer full credit retests. I believe if you show me on a subsequent test that you understand it to a higher level of proficiency, that should be your grade. So they would send the one kid, the one really smart kid, in as soon as the grades were posted to do corrections with me. They would take their retest as soon as possible. When they came in to do their retest, another 5 of them would come in to do corrections with me, distracting me so that one could take a picture of the retest. So they could give it to the other kids, so they could write down what the answers were to the test before taking the test. The class as a whole worked together to do it. When I already give you every resource, that's a whole nother level of depravity. Yes, I did. I no longer do retests, and I'm probably taking away notes, and I'm probably going to be moving a lot of stuff after this semester's pre-calc class. So kids just ruin it for other kids. That's how it works. Both of my sum formulas involve knowing an n, and I don't know n, but I do know a sub n. I know a sub 1, and I know d from one to the other is 18. So 649 is negative 18, and negative 17 is negative 35, plus 18n, add it over. So it's at 684. Is words. Oh.
38.
And now that I know that, I can do the 38 over 2. I suppose I should write the formula. Most kids were fans of this one just because it involved less things versus, oh, what was it? N over 2, something with a bracket, 2a sub 1? Is that it? Question mark? I always goof that formula because it's got too many parentheses. Yeah? Anyone got holy sheets or notes on hand? All right. But again, most kids are going to prefer this one because now I can do 38 over 2, a sub 1, a sub n. Getting 638, 632, whatever 316 by 38 is. I will have all of these formulas up on the board.
Oh, the answer.
Okay, what?
How would we find n to eat the geometric d?
Okay. In a geometric, you have term, 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 dot, 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 term, right? And you don't know what's in the middle, but you do know a sub n. You do know a sub 1. You do know from any of the two terms what r is to the n minus 1. How do I get something down out of exponent land? Logarithms.
Do any of those have?
I probably not. Because I don't think we explicitly did that in class, so it would not be on the final. No. But you can, if you don't know n for a geometric series, use logarithm to find what n is. We have the tools. Find the sum. So now geometric says, now if you want, you can actually list these out. These are small enough. There's few enough terms. There's a sub 1. And every term, I multiply by 3. So negative 12, negative 36, negative 108, negative 324. I could just add them up, right? I mean, there's a small enough number of them. But there's also formulas. S sub n is, let's see if we can remember everything here. A sub 1 minus, what is it, r to the n? And then 1 minus r to the n? Question mark? Someone better have notes out. That formula is correct?
Just 1 minus.
1 minus r, I heard.
No,
1 minus. S of n is, there is a different one.
A to the 1 times the.
I'm never going on Price is Right. And then there's a different one that involves an A sub n in there somewhere, and I don't care. I know A sub 1. I know R to the n. There's 5 of them over 1 minus R. Formula plug and chug. Y'all were pretty good at it. And final law. Specifically find the second term. So I go to the 5th row of Pascal's triangle. The second term starts with a 5. If I don't want to do that, I can also say that if I'm finding the second term, remember this is k, kth term is k equals r minus 1. Or was it the other way around? R is k minus 1. R is k minus 1. Okay. I was going to say, that just sounds wrong saying it. This would be NCR, whatever A is, to the N minus R, B to the R. That was our form. Or you could just go to that row. 3A and B cubed. What a what? Well, I guess we're done. So, everyone's packing up. You've been packing up for the last 4 minutes. I've been just trying to finish. So, I guess we don't care. Reminder, when you come in tomorrow, and so far no one has altered their final schedule with me. So when you come in tomorrow, all of your bags, everything goes up front. Make sure your phones are off. All your phones will go up front. No phone, no final. I doubt that. So bags, phones, everything. Desk will be cleared. You'll clear out your calculator. I'll come around and hand you a final. When you are done with your final, you will find something constructive to do that does not involve your phone. If I see a phone anytime before 11:24, you will receive a 0 on that portion of your final. Books to read are a good thing to do. Yes, we need to turn that in. And the calculator, those are expensive.
Are there going to be certain chapters, like on part 1 and 2, or is it just random chapters?
No, it's in order.